Hello everyone, Mr. H again, and welcome back to my YouTube channel. In this video, we will be learning how to identify the different set operations. So there are 4 different set operations that we will be discussing here. So we have the union, intersection, complement, and difference. So let's begin with the union. The union of two sets A and B is a set containing all elements that are in A or in B, or possibly both. So the notation for the union of two sets. So you have the symbol that looks like letter U for union. So to read that, it's A union B. Now, I have here the Venn diagram below. So I have here the circle for set A and this green circle for set B. And as you notice, the Venn diagram, look at the shaded regions or the shaded areas are actually where you can find all the elements that belong to the union of sets A and B. So for example, if I put in some random numbers inside, for example, I put so A union B is a set containing all the elements that are in A or in B. So basically the shaded areas. So you just simply get all the elements, writing them in a set properly. So you get 2, 3, comma, 5, 7, and 9. So these are the elements that belong to A union B. For the next operation, we have what we call the intersection of two sets. The intersection of two sets A and B consists of all elements that are both in A and B. So this is how A intersection B is written. And for intersection, if you want to remember this, the symbol is an inverted U. So this is actually the intersection. All the elements inside this overlapping section of circles A and B are actually the elements that belong to A intersection B. All right, so by looking at this Venn diagram, if we want to know the intersection of A and B, which are 5, 7, 9. The next operation, we have what we call the complement. The complement of a set A is the set of all elements that are in the universal set U, but are not in A. So there are 3 different notations how a complement of a set is actually written in. These notations actually tell us one thing. This a set that contains elements that are in the universal set but not in A. In the Venn diagram below, you can see the letter U, by the way, stands for the universal set, universe. You have here one circle, like for set A, and the area that's shaded gray is actually the area where the elements can be found, which I'm going to be putting like random elements here. So we are going to write all the elements that are outside of A. This is set A, and the elements outside of A will actually form the set of A complement. We have 1, 3, 5, 7, 9, and 11. Next and last operation, we have difference. the set A minus B consists of elements that are in A but not in B. So if you look at the shaded area right here, so this is where we can find the elements that belong to a set of A minus B. For example, I put some random numbers here. For example, we have universal set actually contains all the elements in the universe. So 1, 3, 5, 7, 9, 11, 13, 15. A has these numbers. So we're talking about the entire circle of A. 1, 3, 5, 7, and 9 are the elements that belong to set A. A set B of 7, 9, 11, and 13. We're going to list down the elements that belong to A minus B. Then it's going to be a set with all the elements that are in A but not in B. We have 1, 3, and 5 only. Include 7 and 9 because 7 and 9, although they are in set A, but 7 and 9 are also in set B. And by definition, A minus B consists of elements that are in A but not in B. Look at this question. The universal set has even numbers from 1 to 15, and then set A is also given. You have 4, 10, 12, 6, 2, and 14, and set B is 6, 8, and 10. Find the following. So number 1, A union B. Look at both sets, so set A and set B, and just simply get everything. But then again, when you write the set, make sure that you don't repeat the element. So we're going to start with 2, 4, but we only write 1, 6, then 8, 10, we only write 1, 10, 12, 14. Number 2, you can pause the video if you want to answer this question. So number 2 is A intersection B. So we're looking at their common elements. So elements that are both in A and B. So we can see that we have 6, that's their common. 10, A, B complement or not B. Instead of the problem, you can draw a Venn diagram if you find it easier for you to answer the operations. So you can have this, the universal set, and you have set A, set A and B, they have intersections. Remember, they have intersection. Number 2, there's okay, you can write 6 and 10. And union of 2 sets. So you have 2, 4, 6, 8, 10, 12, 14. Remember that 6 and 10 are already there. So we put 2 in So actually 2 is actually in A. And then 4 also in A. 10 there. 12 also in A. And 6 already there, 2 already there, and 14. So remember, for set A, we have 6 elements. So you have 2, you got 4, you got 6, you get 10, 12, and 14. And for set B, we have 3 elements only. So we have 6, 8, and 10. And remember, 6 and 10 are already there. So that means the only element is 8. The B only section. And for the universal set, because it says here even numbers from 1 to 15. So what are the different even numbers from 1 to 15? So we're looking at 2, 4, 6, 8, 10, 12, 14. So these are the elements that make up the universal set. Need to cross-check if all of them are already inside the 2 circles. That means that there's nothing outside the 2 circles. Nothing. Because they're already complete there. Now, not B. Not B or B complement. So not B or B complement. So definitely we're looking at the elements that do not belong to B. Right? Very obvious that from there, you can see we have 2, 4, 12, and 14. Obviously, 8, 6, and 10 still belong to, especially 6 and 10. 6 and 10 belong to B, set B. So we don't include them. And for the last one, which is A minus B, basically we're looking at this area right here. So it's going to be 2, 4, 12, and 14. Basically same as number 3. 2, 4, 12, and 14. And please remember to like this video and subscribe to my YouTube channel. Thank you very much for watching.